Favirecon is a powerful tool designed for reconnaissance in the field of cybersecurity. It is particularly valuable for penetration testers, security analysts, and cybersecurity enthusiasts. Favirecon allows these professionals to detect technologies used by websites via their favicons. By analyzing favicons, Favirecon can identify web application firewalls, WAF, find exposed panels, and spot known services. Using this tool can significantly enhance the effectiveness and efficiency of your reconnaissance efforts, thanks to its specialized database of unique favicon hashes. Favirecon's primary purpose is to enhance reconnaissance efforts by leveraging favicon hashes. This tool excels in detecting underlying technologies of web applications through their favicons. It also efficiently identifies the presence of web application firewalls, WAF, and hunts for exposed panels and known services. Using Favirecon significantly increases recon efficiency by utilizing a unique and comprehensive database of favicon hashes, making it a powerful asset for penetration testers, security analysts, and cybersecurity enthusiasts alike.
To get started with Favirecon, there are several installation methods you can choose from based on your preferred package manager or development environment. Firstly, for macOS users, installing via Homebrew is straightforward. Simply run the command brew install Favirecon. For those who prefer using Snap, particularly on Linux distributions, you can install Favirecon with sudo snap install Favirecon. Lastly, if you are a Go developer or prefer to build from source, you can utilize the go install command. Okay, go install github.com/fedora.favirecon/Virecon at latest. These options ensure that Favirecon can be easily accessed and integrated into your existing workflow, regardless of your operating system or development preferences.
Now that you have Favirecon installed, let's delve into its basic usage. The command structure for Favirecon is straightforward. It starts with Favirecon, followed by any necessary flags to tailor your command. First, the -u or -url flag allows you to specify a single domain as an input. If you have multiple domains, the -l or list flag lets you input a file containing those domains. Additionally, if you're dealing with CIDRs, the CIDR flag enables interpretation of the input as CIDR. These flags offer flexibility for different use cases, whether you're scanning a single URL, multiple URLs, or a range of IPs defined by CIDR notation. This segmentation ensures that you can use Favirecon efficiently and according to your specific requirements. On this slide, we are delving into the configurations and flags available for the Favirecon command. These flags allow us to fine-tune our usage of the tool to suit specific requirements. Firstly, the input flags are essential for determining what data the tool processes. -URL domain. This flag is used when you want to scan a single domain. list file. Use this flag when you have a file containing a list of domains to scan. CIDR. This flag allows you to interpret the input as a CIDR notation, useful for scanning a range of IP addresses. Next, the configuration flags come into play for optimizing and controlling the scanning process. Hash string filters the results based on specified favicon hashes. concurrency int sets the concurrency level to manage how many threads run in parallel. -t timeout int adjusts the connection timeout, useful for managing long waits or slow responses. -rl limit int sets a rate limit on the requests being made. -px proxy string allows you to route your requests through a proxy server. By leveraging these flags, you can customize your scans to be as efficient and targeted as possible, aligning them to your specific needs and circumstances.
In this slide, we're focusing on the output options available when using the Favirecon tool. You have several flags at your disposal to control how your results are presented. First, the O or output flag allows you to specify a file where you want the results to be saved. This can be useful for later review or analysis. Next, the V or verbose flag provides detailed output. This is particularly helpful if you need to troubleshoot or want to see comprehensive information about the process. The MAS or silent flag silences all output except the results themselves. This is useful for scripts where you only need the final outcomes without any additional information. Lastly, the -j or JSON flag outputs the results in JSON format. This can be useful for integrating with other tools or parsing the data programmatically. These flags give you flexibility in how you capture and view your results, making the Favirecon tool adaptable to different workflows and requirements. In this slide, we're demonstrating how to use the Favirecon tool to analyze a single domain. The command shown here, favirecon.github.com, specifies the URL of the domain we want to scan. This command initiates the reconnaissance process directly on the GitHub domain. Alternatively, you can achieve the same by piping the domain into Favirecon using echo 8.github.com Favirecon. This approach can be useful in various scripting and automation scenarios, offering flexibility in how we feed input into the tool. In both cases, the -u flag is used to indicate that the following argument is the URL of the single domain we wish to analyze. The same flags and options discussed earlier, such as MAO, V, S, and J, can be combined with this command to control the output format and verbosity.
In this example, we're demonstrating how to use Favirecon with a list of domains. If you have a file containing multiple domain URLs, let's say targets.txt, you can pass this file to Favirecon using the shell flag. The command would look like this: plain text Favirecon-l targets.txt. Additionally, you can achieve the same effect by piping the contents of the file into Favirecon. You would use the cat command to read the file and then pipe it into Favirecon, plain text cat targets.txt Favirecon. This approach is useful when you need to analyze multiple domains efficiently, leveraging the power of Favirecon to process each URL listed in the targets.txt file. Now let's move on to example 3, which demonstrates how to use favicon hashes with Favirecon. First, if you already have a specific hash in mind, you can use the following command. Here we're piping data from targets.txt and specifying the hash directly: sh cat targets.txt Favirecon-hash 7085782229. This will allow Favirecon to filter out only those targets matching the favicon hash 7085782229. Next, if you are working with a specific CEDAR range and want to scan the entire subnet, you can use the CR input option, sh-favirecon-u192168.1./24. By specifying the CIDR, Favirecon will scan all IPs within that range to find and analyze favicons. These commands extend the flexibility and breadth of your reconnaissance capabilities, making it easier to target specific web assets using favicon hashes.
In this slide, we will focus on example 4, which demonstrates how to use proxies and JSON output in the Favirecon tool. First, let's discuss using proxies. Proxies can add a layer of anonymity to your scanning process. To use a proxy with Favirecon, you simply append the PX flag followed by the proxy address. For instance, in the given example, we are scanning GitHub and routing the traffic through a proxy server running locally on 107.0.1 at port 8D80. The command looks like this: favirecon-u-http.www.github.com/107.1 880. Next, for JSON output, the -j flag is used. JSON output is particularly useful for integrating results with other tools or for further automated processing. In this example, we are again scanning GitHub, but this time we want the results to be formatted in JSON, favirecon-http//.github.com/jj. By leveraging these two features for anonymity and JSON for structured output, you can not only enhance the security of your scans, but also streamline the integration with other automated workflows and analysis tools. In this slide, we delve into some practical application tips for using Favirecon effectively. Under efficiency, you can significantly enhance your workflow by utilizing lists with the -l flag, which allows you to conduct bulk domain analysis seamlessly. In addition, by adjusting the concurrency settings using the C flag, you can accelerate your results, making your operations more time efficient. When it comes to security, employing proxies through the -px flag can help maintain your anonymity during scans. Moreover, opting for JSON output via the -j flag is not just about structural cleanliness, but it also facilitates seamless integration with a variety of other tools, streamlining your data processing pipeline. In this slide, we explore a real-world scenario, identifying exposed admin panels. A powerful tool for this job is Favirecon, which leverages unique favicons to detect admin panels. For instance, you can use the command favirecon-u-tps/targetwebsite.com/admin to initiate the scan. A crucial best practice here is to always cross-check the favicons you find against known databases to avoid false positives. This step ensures the accuracy of your results and helps you reliably identify actual admin panels without incorrect detections. In this summary slide, let's distill the essential aspects of using Favirecon for your reconnaissance efforts. First, remember that Favirecon is instrumental in identifying not only exposed services, but also the underlying technologies through favicons. When you run Favirecon on a URL, it helps you detect potential admin panels or other critical endpoints by analyzing their distinct favicons. Make sure to use the various available flags to tailor your scans according to your needs. For instance, you might want to use lists of URLs, adjust the concurrency to manage scanning speed, or employ proxies for a more stealthy approach. By integrating Favirecon into your recon phase, you significantly enhance your ability to quickly identify tech stacks and potentially exposed security measures. This proactive approach allows you to map out possible entry points more effectively and respond to security gaps with greater agility. These key takeaways will help you maximize the tool's utility, ensuring a more robust security posture for your assessments. For further reading and references, you can explore the official Favirecon repository on GitHub at eduardo.com/Favirecon, where you'll find everything you need in the README, install guide, and changelog. It's crucial to familiarize yourself with these resources to fully leverage Favirecon's capabilities. Additionally, consider using related tools such as Nmap, Amass, and Sublist3R to complement your technology identification and reconnaissance efforts. These tools will help you achieve a more comprehensive understanding of your targets by expanding your toolbox beyond Favirecon. By combining these resources and tools, you can enhance your recon phase significantly, identifying not just favicons, but an array of technologies and services exposed across your targets.
Now that we've covered everything in this course, I want to take a moment to thank you for your participation and engagement. Did you enjoy the content? If so, please leave a like and share your thoughts in the comments below. Your feedback is invaluable and helps us improve our future courses. Additionally, don't forget to subscribe to the channel so you can stay updated with our latest content. If you found this information useful, consider sharing it with your friends and colleagues. Thank you once again, and see you in our next course.